it just for a check since
now it started.
yeah,
Okay.
it has started.
Okay. Hello everyone. Good morning. In the US East Coast. Good morning. And then thank you for the opportunity to present the paper I wrote last year. The paper I was really focusing on is try to enhancing the Shiller's K model, which is the cyclical adjusted P ratio. The topic is actually pretty straightforward, but so let me directly go here. So before I dive into that, I just want to show the problem statement or see what's going on, why we want to do that. It's really an elegant model from my perspective that like the Shiller created the CAPE, using the CAPE to predict the 10 years equity return. And it's I would say that's kind of like the cornerstone, like we are using for long-term equity return forecasting or CMA, or let's say the strategic asset allocation. But this model is not really works well after, let's say, 1985. That's what we found, as we use that as well as a foundation. The key reason we found is like the model is really elegant, but it's oversimplified. As you can see here, as you can see here, it's really just a linear regression, right? So like 10 years after today's return, annualized return is really a single beta and multiple beta CAPE. So in reality, the market involves structural shifts, the microeconomic cycles, policy regimes, all affect the valuation dynamic. The key assumption during the original shape is really valuation will convert. So when the valuation is high, equity return will be low in the future. But even that holds, like the convergence rate should be dynamically, right? So it's not always hold the constant convergence rate. It should be based on something. Sometimes you convert faster, sometimes you convert slower. How to do that dynamically is the problem we try to solve. And then our research contribution, I want to put it in the front. So the CAPE is a use case to enhance the CAPE. So the key contribution, I would say, is like we design an all-new algorithm called CCLR, so which is conditional clustering-based linear regression. So this is not some model already exists. This is all new. So we design from ground. So CCLR can include two parts. So the first part is really CLR, which is to cluster. So after we cluster that, we build different models, and then we adding another C to make it smoothing. So it's really 3 steps. So we clustering that to different group, and in different group we regress, and then we how to smooth that. So that's actually what we build. So on these two parts, the first part is CLR, and the other part, as I said, is really the how to build the transition. The third part is also really, I will say, important. The reason is, as I said, the problem we try to solve is the market involvement, structural shift, regime shifts, and how that will impact on the valuation behavior. So for the narrative or for the clients or for the meaningful economic sense, we want to understand if the regime we build actually has some economics meaning, right? So we before they get a single beta, now we get a multiple beta. And then each regime, when we determine the beta, if those regime actually get any micro meaningful there. So those are 3 steps. CLR clustering based linear regression, how to smooth it, how to connect it to econ, 3 steps. Okay, so the next part is really, this slide really shows the bigger picture. So our methodology include the 3 steps, as I mentioned before. The first step is really identify the valuation regime by clustering the CAPE value. So here is really a straightforward example that we clustering on the CAPE value. And the second is model each regime separately. For example, when we get 3 regime, and then in each regime, we can do a regression. And then finally, stabilize the transition with a conditional approach to avoid regime shifts. So I will show more details, but what we try to do is when you turn from one regime to another regime, during the regime switch period, if you get two separate beta change a lot, so it's going to be really impact your long-term asset allocation decision, which based on either the modern portfolio theory or Black Litterman, it will change a lot. So that's not what we want it happen. We want is more practical. So that's what we have. So identify regime, model within the regime, and stable the transition. Okay, on the first part, the first part is really, as I said, the first time we try to clustering the K and the regime regression. Before what we show, I want to go back and then to show you. So when we have a single beta, it's like the downward trend, so which really follows Shiller's hypothesis. When the valuation is high, your return going to be low. So that's like a negative. What we found is after you clustering that, the assumption still holds. Higher valuation means lower return in the future in different magnitude, right? So that's we are adding another part. So when we clustering that, you can find that for this part really steep. That's basically means when your valuation is really high, and then it will impact on your future return more, and sometimes more flatter. Then you can see we got 3 cluster as example. So because we are building that dynamically, I don't want to building too much cluster, and I want is fully dynamic. So when you are using k-means, you will basically just using elbow to find the optimal cluster number to have to determine the cluster, and then you do regression within that. And in each regime, we are using linear regression. That's why we call that a linear CCLR, right? Cluster-based, conditional cluster-based linear regression. The reason is we really want to know the coefficients to understand it. So like what I originally built is CCNR, which is nonlinear, not really limited to the linear regression. But what I really found first, when you split the whole time series to be different regimes, and using a pretty reasonable rolling window, the nonlinear not really can add much value. But in some cases, maybe. But in this case, because we do have a linear assumption that higher valuation means lower return. So it's really just about your coefficients in different degree. So that's why it can give you more transparent. And the second part, as I said, so after we clustering that, and then we have the regression in each group. So the CLR you can find, for example, here is really the pandemic part. Then you can find, okay, we from one regime to another regime, and then go back to another regime. This actually shows our model works because during that time, the market changed a lot. It should be in different regime, but this will significantly impact our asset allocation decision, so which is not good. And we want is more stable to kind of average on that. So for that reason, we want to focus stability. And then after we're adding conditional, it's become smooth out. For here, I want to talk more about how we do this innovation to ensure stability in here. So for example, we have 3 clusters. In each cluster, we have individual beta. If we turn from cluster 0 to cluster 1, let's say we switch from regime 0 to regime 1, during that transition period, we will combine these 2 data set and building a beta 4. So the beta 4 is like a smooth averaged 0 plus 1. Similarly, when we turn from cluster 1 to cluster 2, we will combine the blue and the green together, building a new beta, which actually between your beta 1 and the beta 2. So we got beta 5. And when you turn from 0 to 2, you get beta 6. So which basically means we got 3 foundation beta in each regime, but you also conditional on current regime, the last period of forecast, which regime we were in. So if we are in the regime 1, before we also in regime 1, we're just using beta 1. If today we are in regime 2, yesterday we are in regime 1, then yesterday we are using beta 1, and then beta from regime 1 and 2, and then becomes regime 2. So we are building a conditional based on what regime before to make sure that the transition can be smoother. That's actually what we are doing here. By doing that, you can actually handle a lot of structural break much better. Just like we know that's transition from one regime, structural break, to another regime. The structural break will not directly from 1 to 2. Okay. And then the next part is really the accuracy. You can see is actually much better as it should be. The reason is the original K model is not bad. To be honest, what we really appreciate is the key assumption built by Schiller. It's higher valuation, lower return. That still holds. We're just adding another layer on that. So like how high the valuation leads to how low the return, how low valuation leads to how high the return. So we have different regime gave you more tailored solution than gave you just one set solution for all the regimes. But that's how we build it. So on the left top chart, you can see that is like, you can see still we have some part here and here, but most of the time is pretty well, because still the input is the cape, still holds the original assumption, but we're just using the algorithm to tailor different convergence time. And when you are using the rolling model, so what I'm using 120 months rolling model, so every 120 months, you basically will recluster that and found the best coefficients and also the transition coefficients. That's how we build it. That will help us to give more weights on what's happening in recent 10 years or 20 years as you wish, but what I'm showing here is 10 years. And here's the last part. As I mentioned, 3 parts. One is the regime, another is smoothing. The last part is really, let's see if here is anything is really interesting. So the orange bar, what you can see is really the median, so which is interesting. So you can see, yeah, so in different convergence, valuation convergence regime is actually here is some information there to connect it to the microeconomics. Because here, the reason I'm putting here, even in the paper, what I mentioned is in this model, it's really just using CAPE single factor, right? We are trying to using single factor CAPE to improve that, to cluster. But in reality, you can improve that in a lot of ways. So you can clustering on CAPE and, for example, your CPI in CAPE and other stuff, your CAPE lag or stuff. And using that way, then you can always using this framework to connect if your regime by clustering different stuff still can have a clear micro story. That's actually why we put in there, because like when we're building pure technical model, we always want to have a narrative there, because the shape model, the Scheller building the CAPE model is a micro-driven model. And then I'm preparing some questions. Is like could we try to enhance and answer something here? First is why not using the deep learning and the more complicated and machine learning model? As I mentioned, the reason we are using, for example, here 6 beta, right? So linear regression. Why we're using the linear regression and clustering those stuff? Well, by the end, it's an enhanced linear regression model. It's simple. It's pretty accurate, and we can explain that by coefficient. So even just through the time, we can see a time series the change of the coefficients. The second one is like about the cluster. So what I'm using example here is really using the k-means. During the paper and when we're building the research, I actually tested multiple ways of the clustering. But because here it's really just one-dimensional to clustering on CAPE itself, but try to enhance that. is through using k-means is already really good and robust. And then the third one is really if that will be work on non-US market. The answer is still depends on if the valuation, high valuation drives lower return holds in that market. From we are improving that and tailor another layer of that. So what we tested is during the during the DM, developed market, the assumption holds and the result holds. So it still can improve a lot by doing this. But in the emerging market, it may not, because it's still not really, because the CCR or so that's improve your based on your valuation driven return stuff. But in a lot of markets, not really just valuation drive. But from that perspective, we can actually, as I said, valuation as one factor, adding another policy factor, adding another local regime, global regime, adding together, and then you cluster that, then do regression, and then it can solve a lot of good. That's actually one of the next step. And then during the structural break, so we found the first is rolling window is really helps. Like rolling window, we don't want too short, we will be really jumpy, but select the best rolling window and then clustering in that rolling window to predict the next term, always helpful. And also, it's really if we are just using, back to the question one, it's not really, it's about the accuracy and the simple. But also when you are just using the nonlinear model, it's not just really hard to understand what's going on. It's also the accuracy is not that improved. Plus it jumps all everywhere. Right. So the last one, the 6, as I mentioned, is really you can combine other stuff, right? So what I'm putting here is really the valuation, but from some of the parts perspective, you have valuation, you have your dividend yield, you also have your earnings growth. So you can actually cluster a lot of stuff for tailor the market and for the explanation. So that's really the framework we try to present. And then, so the last page, what I want to show is really it's improved the long term, because that's our use case in this paper. For sure, it's improved. It's scenario based because we're still trying to understand it. It's not really just a black box and we don't know what's going on. So that's the highlight of the paper, is everything is practical and really easy to be accepted. And the third one is really is connected to the second one. So we will understand the valuation convergence rate, how that will connect to the policy and the macro. And the key takeaways is really the CCR restore the K predictability by adding another layer and to tailor that. And also is a bridge the valuation model and the macro economics context by the regime. Okay, 20 minutes.
Thank you, Daniel. But you would have 30 minutes in any case, So if there is anything that you want to add, please add it. If you really think that this is all, we will start with questions. First, in general, from reviewers, but in any case, we welcome questions from everyone. Yes, please use the hand tool. I see Vincent did that as well. Please, Vincent.
How is your approach different from a broken line regression? It would give the same interpretability. You would have something linear. You would have automatically the smoothness because you can force the broken line regression to be smooth. And if you wanted something even smoother, you could use some linear regression with splines, which is as interpretable.
Okay, so for your question is like what we are building here. The first step is using clustering, right? So why we are building this stuff based on clustering, not something already exists. The reason is this is one of the use case. And actually, I recently published another paper is like we are not really just do the single dimensional clustering. So we can pretty flexibility to find the regimes first. So we want to have a definition of that regime. So when you have multiple factors, we want to put the other to determine the regime by a lot of factors. And then to understand, give the regime a name or to understand how regime connected to different stuff. But on your question, how to smooth it, but how we build it is really, so what we're building here is that we only clustering our independent variable. We are not cluster our dependent variable to make sure it's purely out of sample, right? So in the future, you know which regime we are in, and then we do the regression on that. And then clustering, the conditional is based on that. So if you say, if here's anything different from something else, I will say it's like the framework we are building is kind of more flexibility, and then we can give a lot of the flexibility to add other features, the micro and other stuff. Yeah.
Okay, thank you, Daniel. Now Tan has got a question. Tan, please.
Yes. Well, great work presenting this really rigorous framework. I just want to comment real quick on your answer addressed to Vincent. Is the novelty just as important as the relevancy, especially in the buy-side world and mutual funds, where the model complexity are just as important as interpretability? So I really appreciate that part, that the model can bring in, can link to the economic narrative. I think that would be really practical adoption. I guess my question is, in your number 6 anticipated questions, you kind of like explain this can be extended to other predictors and other time horizon. I was curious, have you considered extending this logic, this framework, to other asset classes other than just shorter forecasting horizon? Like, for example, I can see this conditional regime and also smoothing framework can also be adaptable to credit spreads or FX or commodities, where there's also a valuation anchor, but a convergence depends on the speed of the convergence. The path really depends on the market conditions. So curious about whether you have considered other extension.
Okay. Yeah, thank you for the question. So the CCLR we build is based on one assumption. So like, I really appreciate that you are thinking of using other use case. I will say, as long as the original assumption is a linear relation, you can always using CCLR to add in another layer by turning one single beta to multiple beta by regime based. Okay, so as long as your original idea, they are linearly related, I can always find a different beta instead of one average out beta. So for your question, for sure, you can use it. And another good part, as you mentioned, is the benefits part, I would say, is because we are using regime. So when you are saying the credit spread or so, you can still try to using the same framework to connect the regime in credit spread beta regime to your domain, like the credit spread. If that will connect to recession, connected to different like the real yields, those different stuff, you can check if that's connected.
Okay, thank you, Daniel. Robert, please.
There are a couple things that I guess were not clear to me from your presentation. I don't see, first of all, how long the sample period is, and what actually, whether the regimes are contiguous in time. In other words, does the 0 regime include a bunch of dates which are next to each other, and the same for 1 and 2? My interpretation is that these regimes all are clustered in time. Is that correct?
Thank you for your question. That's really helpful. So our time period is actually from back to 1980 something to 2024. So it's really a long time period, long time. 1920, I remember. It's like I'm using Shiller's yield website, so his data all the way to 18 something. So your second question is really important, Rob. Is that if cluster 1, cluster 0, those are all connected, they are not. So when we're building the beta, is that we break the time series and cluster it.
So you can switch back and forth from one regime to another, and
Yeah.
and at each time you've got a smooth transition.
Yes. So as long as you switch from one to another, we need to smooth it as conditional.
So these clusters could be defined in terms of macro variables then.
Yes, exactly. That's why we want to make a connection there.
And so what are the macro variables that give you fast mean reversion versus slow mean reversion?
Here is what we found. So I will say what you mentioned is more about like if we can using micro variable kind of to predict which regime we are in. But here is more about like a descriptive. So like in each, the reason I'm putting here is like you are seeing cluster 1, 0, 1, 2 is based on the whole data set until the last day. So that's the last regime, right? So include the last one. But actually, when in the practice, as I said, I'm using 120 months as a rolling. So every time you add in one data, I will say like we recluster it. So every time the most robust way I will say is really building a kind of a regression or classification model. We'll understand which key micro variable really drives. But from my understanding, actually, it's pretty straightforward. It's really the real rate inflation, 10 years real yield, which really drives the equity valuation, will also drive how valuation convergence rate. That will be a great next step.
So one of the questions that I think we should address is the CAPE model as important today as it was, 30 years ago?
Yes.
And your regime switching kind of disguises the answer to that question. I don't know for sure whether the regimes are now more likely to be slow convergence than they were in the past. And I don't know whether there's an economic argument you can give for why these particular values of the macro variables would lead you to expect that.
Yeah, I understand. So for your first question, if CAPE is still useful, I will say is like CAPE is just a factor. What really, if useful or not, is if valuation still can predict equity return. I will say in this way, right?
Right.
I will say for the strategic asset allocation, that's still the most common use in the institute, right? So like because we can base on a lot of other ways, I believe, but using valuation is still like the mainstream in the institute right now, I will say, like across the BlackRock, as I know, Vanguard, like we are doing that, still valuation. But we do have some of the parts. So like we have valuation, we have earnings, we have these different part to discuss, but the valuation is still the key driver, one of the key driver, right? So what I'm thinking is like if we can still leverage the part of we got valuation, dividend, earnings, but if on the key driver valuation side, if we can still using some tweak and the regime as Rob, as you mentioned, in recent time, it was convert faster or slower or whatever. If we can figure that out, that's my hypothesis. If we can figure that out, then I can put CAPE back to relevance. So if, for your question, if it's relevance right now, no, because it's not accurate since 1985. It's always not working. But is that because the hypothesis is not working or the original model approach not working? That's what we try to make sense. If the assumption still works, we can make the model a little bit better. Maybe still can generate a lot of value based on original elegant approach, which is like simple linear regression with oversimplified, but easier for clients and the portfolio.
Well, I guess I'd like more of an economic story.
Oh, I know. That's why I put there. Because if it's not there, it's gonna be a pure mess. Like just cluster it and smooth it. It can be better, but
That's
why
right.
it work? Yeah.
My view is that you're not really done yet until you can tell the economic story.
Totally. Yeah. That's actually real issues that what I build is this is just a foundation of the CCLR, a showcase, but the real piece is like what I'm thinking like I'm clustering cape here, but I also clustering the valuation correction speed cluster together to build a model actually can predict from 1 year to 10 years. So that's multi-horizon, which I recently published. I will follow up with you on that because that one will include all the economics written on that.
Okay,
great. Thank you.
Thank you, Daniel. Thank you, Rob. Please, Marcos.
Thank you, Massimo. And I agree that without an economic rationale, empirical findings are suspicious, or we will never know whether they are true signal or noise. So I would encourage you to pursue identifying what is the economic mechanism that would justify these findings. So I have two questions and one remark. The two questions are, number one, did you cross-validate these results or estimated statistical significance of the root mean square error? I saw that you're reporting that, but have you checked that it is statistically significant?
Yes, exactly. You know, the reason is for this model is actually really straightforward, but for the reason is like we are basically still using CAPE, right? It's like still just the CAPE single variable regression. It is even significant during original Shiller's CAPE single beta. When we tailor that to different regime, I tested it's all significant because it is a significant factor. But
where can I find that in the paper? I'm looking at the exhibits 12 through 16. But I see you are reporting the RMSE, but I cannot find p-values or confidence levels. Is that something that you did, but you didn't include in the paper?
I'm maybe not in the paper, but yeah, I can definitely, that's a good question, but it's there. So I can quickly just follow up with you on that, if you're interested in that.
Okay. The second question is, I presume you computed more than one backtest.
Yes.
And did you adjust the results for multiple tests?
Sorry, what do you exactly you mean?
Yes, you have computed multiple backtests, and presumably you are showing us the best results out of all those backtests.
Yes.
And the expected value of the maximum or the best result, in your case, the expected value of the minimum root mean square error it will be biased as a function of the number of trials. So did you correct those values by the number of trials?
Yes, for sure.
Is that in the paper?
Yeah, so that's actually what I mean is what I really try to show in paper is like to compare for the baseline. But in my the example as you mentioned, I put there is really just the results to show how the trend we can follow better if we do conditional clustering. But for all the detailed statistics, I just kind of afraid of will pivot the audience on that. But if you're interested in that, it's out there. I can send to you. Yeah.
What method did you use to perform that adjustment?
So I want to make clear understanding on your adjustment. You said is like, you say again, it's like, you said that we run different backtesting. Yes.
Yes. So there are two families of multiple testing adjustments, right? You have the family-wise error rate that adjusts by the expected value of the best result. And then you have the false discovery rate approach, which controls for a certain proportion of false positives.
We basically, no, we didn't use the second one. Yeah. No.
So did you apply a family-wise error rate approach?
Yeah, I don't know that family.
Which one? Bonferroni, Sidak, Hochburg. There are many approaches.
Yeah, I need to go back and then give you more details. But for sure, we did the model validation.
Okay, no problem. One final remark, and it's not critical. The elbow method is is quite primitive and is subjective. It involves human judgment. I would recommend that you try the silhouette method. I know that in your results you check for robustness, and that's good. You saw whether 4 clusters would change dramatically versus 2, and that I appreciate that. But I don't think at this stage the elbow method is recommended. You could try, for instance, a silhouette score approach.
Yeah. So for that question, yes, we actually tried, even from the paper, you see I tried the CK1 and tried the hierarchy and also k-means. The elbow one, I will say, is not really try to use elbow to find the 3 or 4 cluster. The elbow one, the reason is like, as I said, the baseline is here's no cluster, just Shiller's original K for regress single beta. So even you have 2 clusters, it's already better, right?
All right, thank you very much.
Yeah.
Thank you, Daniel. Thank you, Marcos. And please, Jorge.
Okay, thank you very much. Thank you, Daniel, for this interesting presentation, and congratulations for the interesting paper. Most of the questions actually were covered by the previous colleagues who asked questions, but I'm still a bit unclear about how robust your results are. Suppose instead of let's say this amount of data, you had partial amount of data, you had, did you check for outliers? Did you check how much, for example, trying to do 4 clusters or 2 clusters would change your p-values and your results?
Yeah, that's actually a real good question. We tested, so I tested from 0 to 5 cluster. And then what I found is like the more cluster you have, that's actually will lead to, you need kind of longer rolling window, right? So if you got too shorter rolling window, you got a lot of cluster, actually will make your model really jumpy. So that's why we kind of like settled at 3. And another question, as Rob mentioned, is really, we don't want too many cluster that will really make our explainability with economics narrative less, right? So for example, when we have 6 cluster, it's really just average out what our 3 cluster to additional 6, right? And then when we try to make a more statistic significance to the micro driver, going to be really difficult then. So that's why we kind of settle with 3. We found it's pretty robust. It's not too much, but it's also meaningfully improve the results. But from pure statistical perspective, you get more regimes. It actually can tailor that stuff more detailedly, like can make it better, but it will decrease your capability to explain the regime.
Okay.
Yeah.
All right.
Yes.
Thank you very much.
No problem.
Please, Enzo.
Yes, thank you. I just have a quick question. I heard you mention, I think, a reclustering procedure. I just wanted to ask you about what kind of prevention you have in place for look-ahead biases coming from, I guess, when you build the clusters, you have a view of all the data. Yeah.
So the key innovation I will say here, as may not be innovation, but we clustering on independent variable only. So for example, we are today, so we only cluster on the independent variable, let's say 120 months before CAPE, right? And then when the new CAPE comes in, I tell you based on historically which regime it belongs to, and then we pick that beta from past 120 months, that regime, and then use that to calculate the return. So here is definitely no look-ahead bias. If you're clustering on base independent, two-dimensional, you're clustering both your independent and the dependent variable, there will be a look-ahead bias because you only know CAPE, you don't know 10 years ahead return. So how you can know which regime you are in? But we only clustering on the X, your independent variable.
Okay. So if you run this model and then you have 1 more month of data, you'd rebuild the whole history, rerun the whole thing.
Yeah. Yeah. Monthly. Yes.
Okay. Thank you.
Thank you, Enzo. Thank you, Daniel. Are there any further questions? Also outside reviewers? Okay, in this case, I thank you all the reviewers, all the participants. This one was the last paper among the finalists in the competition. I remind all the reviewers to watch the videos if they have missed some presentation, and then the form, the sheet that is available for evaluation. Thank you very much, everyone. Really thanks. It was a great competition. Thank you to all the participants and to all the reviewers.
Thank you.
Thank you very much.
Thank you.
Thank you very much, and good day for everybody.
Thank you.
Thank you. Bye.